guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you can take a minute and hit subscribe, I greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Well, good morning. This is going to be the first segment that I actually get to shoot. I have to shoot this little bit all out of order. This is be a multi-month build that we're starting. I got some time to kill this morning. It's coming up in temp. It's at 263 degrees. This is a solder pot that I traded for. This is one of 4 that I now have. And I've got to use it to do some Anderson clips and some eyelets for this the 667 I'm working on. You guys are going to see this video. It's going to come out in January on the 667. But what we're working on this morning here, we're going to look at over here on this computer screen. So let's go ahead and get this pulled up. I've decided that I'm going to build myself a set of twins. And what I mean by that is, I don't know, I have this burning desire to build a set of matching 3000s for some reasons. I don't know why. I had one friend, he come to me and he just desperately wants to get himself something a little bit bigger than a pillbox, and I just can't stand sending these guys away. So we've been talking about this now going on 3 years, and I've finally decided to start moving on this project. So I've got a list of things I need to purchase to actually make this thing happen. So I just went to Newegg right away, and I pulled up on Newegg this little cabinet here. This thing's beautiful. I think this is what I'm going to go with. The dimensions of this cabinet here, the static load is 1,700 pounds. And of course, it's going to be more than that, because what we'll do is we'll go down here on the bottom of this cabinet in here, and we'll probably go get ourselves 3/4 of an inch or a 1/2 inch plate of aluminum, and we'll insert it down underneath the wheel brackets to help support the base of this thing. I have this goal to build a 3000 like really at a top level, like super pretty, super cool, very, very professional. All the plugs pulled out, not just 2 aluminum boxes that we bought off the internet and we crammed crap in them. I want to go to that next step with it. So I built Vader. I built a 10,000 before that. And Vader, the way it worked is I got a 3000, I ripped it completely apart, took half the parts out and threw it in the trash. Ended up buying a new amp deck for it because it was a Henry regenerator cabinet that was in the upper portion of it, and it wasn't going to work the way I wanted it to. So took the socket from that cabinet, and then I built my own 3000 basically inside that old cabinet, repainted the cabinet, the whole 9 yards, changed how it was wired on the inside, broke a bunch of stuff, learned a bunch of stuff, got taught a lot of stuff, and I went forward. So first I built a 3, then I built myself a 6. And once we get a little bit farther into the segment, you're going to see how quickly and how fast the 2 tubes, I mean, like, I think of the 6000 as a cheater tube, right? All you got to do is increase the plate voltage on a little bit and back the filament voltage down a little bit, or up a little bit, and it, because the anode's bigger, it produces you can make it produce a lot more power by putting more voltage on the tube. The other thing I finally figured out when I built the 6 is that I realized that the tube is not the core of the amp. Okay, that is not the nexus that the whole universe goes around. That is the plate transformer, your basic power supply. That is the hardest thing to support. I mean, that component is in turn supporting the tube, but the tube is, in my opinion, the kind of afterthought. So when I decided I was going to go and build my own 3, that's when I came across this company called electronic product design. So we're going to roll back around to them here in a minute, because the next segment after this segment you're going to see is us talking with EPD. I called them yesterday and spoke with them. But the primary thing that annoys me in amplifier construction is the use of wood. I've got a 3000 that's sitting on the floor, or not a 3000, a 1500A7 that's sitting on the floor behind me, where the transformer is supported by a 1/4 inch thick piece of plywood on the bottom side of an aluminum cabinet. I will never build using wood. It's unsafe. It's not how anybody professionally does it. And I would personally be ashamed if somebody paid me a couple $1,000s to produce something for them, and the best I could come up with would be a hunk of wood or the power supply in a wood box. That, not my style, bro. Now, what we're going to do is we're going to take this cabinet, because I know there's no way that this cabinet is going to be able to support the weight that we're going to put in it. So this is the base of the cabinet, and we're going to put ourselves a nice heavy-duty plate in the bottom of it. So you got to think Vader shrunk down. So first I built a 3, then I built a 6, then I built a 10, then I went on and built a 15, and when I built the 15, that was Vader, and Vader has now morphed itself, because I originally spec'd the transformer on a pair of 20s, full out, full chooch, under load. Well, that's when I realized I don't need to do a pair of 20s. I can do a single tube, zero support, less air I've got to move, less current that the box is going to draw, because we're going to have a single filament. And I was able to go out and track down the last 40,000 that was in existence at that time that we knew of publicly. Well, it wasn't until a year and a half later, when there was a couple other 40,000s that surfaced. We didn't know they were around. So anyhow, Vader morphed itself into a 40,000 just simply by me moving 2 wires and changing out the filament transformer. All of a sudden I can run a 40,000. That's a huge leap to go from, out of one cabinet, I was able to utilize one cabinet, one plate transformer, and I was able to run a 10, a 15. I could have theoretically run a set of 20s in it, or I moved right on over and went to a 40. I want to provide that same flexible option to my customers if they want to buy something like this. So I personally think Henry cabinets are ugly. There's a lot of cooler cabinets out there. This is a neat little cabinet. It's got a glass door on the front of it. I think I'm going to etch my BBI logo here in the front. We're going to put a name down here in the corner. You're going to see what that is coming up here shortly. If you don't already know, because I've already started talking about it publicly, people are going to rack that little bit of information away in their brain, and they're going to remember. So somewhere right about in here, I'm going to have what the name of the amplifier is, and up in here I'll put my logo. But it's got a twist handle, so you're going to put a key in it, turn a key, handle's going to pop out and turn. This is neat. All steel construction, a modular lattice line on the inside. So what we'll have is down here on the bottom is we're going to have our plate transformer, and then up about halfway in the deck, or in the amp, we'll have another shelf, and in here we'll have our filament transformer, our time on circuit, our time off circuit, our soft start, all those kind of things. And then isolated, well, then we'll put an aluminum, we'll probably actually use plexiglass, a plexiglass plate that'll have all the meters on it behind the door, and then above that we'll have access to the amp deck, which is going to be in its own separate isolated RF shielded enclosure. And that means all the high voltage will be on the back side in a shielded cabinet, and then we'll have the amp deck on the top. We'll probably have the coax fittings come out the back, out one of the back panels. This has got fully removable doors on it. It's fully louvered, fully ventilated. It's got slots in the top for 2 high flow 120 millimeter fans. We'll probably stick a 400 or 500 CFM 220 lift blower on the top. So we'll do just like what we did with Vader and make it a lung, where it pulls air in at the bottom, it circulates up through the cabinet, percolates, and comes out the top. So let's get on to the fun bit. Now we're going to go get the tubes. So I have a couple 3000s sitting around here. As everybody knows from some of the videos I shot in the past, this is a 3cx3000a7. This thing's 100% bad. The filament on it is pulling way too much current, and as soon as you apply anything over about 1,000 volts to it, this tube shorts out. So you got to create the amp to support this all the way around. Now, let's look at the spec sheet here. This is going to get fun. And this is where people are going to start losing their minds, the way I think. I'm going to need me a post-it notepad because we're going to take ourselves some notes. I'm going to need me a hieroglyphic writing tool, otherwise known as a pen. Okay, so we're going to come down here and look, and it says very clearly, let me zoom in on this so we can get a little bit higher resolution going on. Okay. We know that in AB2, plate voltage 5,000. Okay, it's going to pull approximately 2.5 amps worth of draw. Plate volts 4,000 volts. Plate current amps. We're going to remember this number. Okay, output power is 10,500 watts. That's not where we're going to run the tube, but we want to be able to provide the flexibility for that. So if we go and look on other data sheets, you're going to see that this number is a variable. Okay, it goes up and it goes down, it goes up and it goes down, depending on which data sheet you look at. This is CPI, IMAC. This is their particular data sheet. So we're going to remember this number. We're going to come over here, we're going to punch in ourselves 5,000 volts. Okay, this is how most people would go about specking the transformer. They're going to take that 5,000 volts, they're going to divide it by 1 point. Now this is another variable. Let me get this over here in frame. You take that 5,000, we're going to divide that by 1. Now it depends on the builder. Some guys use 0.45. Me personally, I'd rather be high than low, and I'll explain that in a minute. 1.45. And then the guy that's actually going to build the transformer for us, he uses 1.41. Now there's a lot of different books out there that tell you how to arrive at this equation a lot of different ways. There's going to be a lot of different websites, and the guys are going to have a lot of conversation about this. I'm going to go with what I know personally works. I'm going to run off the numbers that the guy that actually is going to handcraft from nothing to a completed device for us, the transformer that we want, which is going to be EPD. So that means we're looking for, on the low side of things, I'm sure I still got this in frame. This is how normal most people would spec the transformer. They're going to take this number, they're going to divide it by 1.41 because we know that's the mathematical number that the designer is actually going to use. And so we're going to ask for our secondary tap on our transformer to be approximately 3,550 volts, round up. Because to get this precise in digits, not going to happen. All right, well, that gets us a floating 5,000 volts. 5,000 volts. Yeah, I'm not interested in that. I seen a post the other day on Old Fart Book where a gentleman posted a very simple question. The question that he posted was, why do all power supplies sag in high voltage, amplifiers? And the very simple answer to that question is they're not regulated, okay? So as I'm wearing out my callus that's on my left hand and I'm thumbing through, I'm reading the comments that are below on this thing, and I simply put up my response to the question. It's not regulated, period. That's going to be your primary determining factor in most properly spec'd power supplies. The reason that the voltage drops is because it is not regulated. Now, you got to remember, regulation means two different things. It's going to regulate the voltage from climbing excessively too high, and it's going to keep it from dropping certainly low. It's easier to rectify down than it is to rectify up by far. Okay? So, I was reading through some of the comments, and some of the comments that I started reading of this other builder who buys and uses a lot of Henry components, just kind of made me sit back and wonder, and I just kind of sat there and I just kind of tapped my thumb on the phone. I'm thinking, man, I don't know if I go and do this. Look, we're in a very interesting position now, you guys. America is not what it used to be. It's not. Most of the transformer production in this country has been gone overseas or out of this country. Either it's in Mexico or it's gone to China. So when it took off and went to China, because everything we basically consume in this country is manufactured in China. All the copper, the steel, that kind of thing. Most of that stuff, I'm not saying all, but most of it is manufactured in China. And that's because of the EPA. And the operating costs in this country, for a lot of different reasons, that and labor is much cheaper overseas than it is here. A lot of things happened. Now, this guy is a staunch Peter Dahl supporter. And he went nutso on this post. I don't understand why. He went on to go rag and rag and rag and rag and rag and rag on electronic product design. And I'm thinking in my head, I'm like, wow, I don't think that's really a smart move. Let me explain to you why. You cannot call up Hammond, and that's the guys that currently own all the licenses, the rights, and royalties, and manufacture, Peter Dahl Transformers. When Hammond came along and they purchased the designs from the previous owner, when Peter Dahl went out of business, it was because he couldn't make any money at it. He went out of business because, well, the business started moving into Mexico because it was cheaper to get Transformers produced in Mexico. And the manufacturing monster that he was collapsed. Now, there was a lot of other things that went on behind the scenes, some personal issues that took place, lack of attention to his own business from those personal issues, which we can't blame him for. And the business got sold. Well, the first company that purchased it, they were after the transformer designs for the amateur radio kind of manufactured production, the smaller end, 3,000, 4,000 volt and down kind of production. Hammond come along and purchased it from them after they couldn't make a go out of it because the production of transformers wasn't steady enough. Hammond bought it and they wanted the commercial designs. So there are lists and specs and call this number and that. They're on the internet. I don't know if you guys have ever tried to actually call them and successfully purchase a transformer. I have. It did not went well. Actually, I ended up getting nothing. So I ended up asking around, and my teacher, my mentor, and my very good friend, Prime Minister, says, "Oh, no problem, man. Go talk to these guys." Now, I'm not saying they're the only show in town, but they're the easiest ones to get a hold of. There are a couple other producers that build transformers in the United States, but it seems like for them to work with us, the little guys, it's not worth it. The onesies and twosies to them are not. There's not enough money involved for it. So unless you've got an in or somebody there at that company that's willing to take you on, forget it. The off-the-street guy that wants to go and take on a project like this, you're going to have to call EPD. Now, that being said, I bought some EPD iron, and I was absolutely blown away with how well it works. The computer modeling program that he's got is top-notch. It's new. It's not a slide rule-based technology like, well, gotta keep letting it slip out of my head. I don't know why. The Peter Dahl designs. I'm sorry, those are all designed with slide rule. And we're talking slide rules that are as big as a room and they're round. Okay. His modeling program is top notch. My first experience with him is I actually ordered some drop-in replacement transformers for an X-Force base station because I called X-Force and the gentleman that ran X-Force at the time cussed me out on the phone because I cost him too much of his profit margin and hung the phone up on me and refused to sell me the components. Come to find out later on it was because the transformer machine was broken and he found out it was cheaper to go over and use switching supplies and abandoned it, and that's when the design had changed, and this was post-Carl. Carl and Carol were such a dream to work with. I miss them greatly. Anywho, I got these transformers in, and they fit directly drop-in blueprint for the transformers I took out. The problem is their one transformer that they rated at 100 amps produced 3.5 times the amount of current that the transformer it was paired with, and I ended up taking the other transformer out and setting it aside for parts and sending this amp back with just one transformer in it instead of having to have two. And that's because his modeling program called for a much larger secondary that had more surface area, and he used thick copper flat strap instead of a wire mag-coated thing. What I'm getting at is the transformer outperformed everything that had come before it. Now, I've had a lot Peter Dahl transformers come through here over the years. I've had some that work great and others that I thought were weak and sagged out their asses. Peter's is not that. That stuff over electronic product design is second to none, in my opinion. And the fact that this gentleman, if you called him with questions, he'll, like the first time I ever met the man, I've never met him physically, but I mean, talked to him on the phone, he recognized that I had some questions. He recognized that I wasn't too sure about what I was asking for, and he sat down and explained to me the entire process beginning to end, and it took 3 hours of his day. That was conversation number 1. Conversation number 2 was equally as long, 3, 4, and 5. We have a very good working relationship with electronic product design, and I hold him in the highest regards. Peter has been working with designing and hand wrapping transformers since he was in his teens, and he's now in his late 80s. And they are desperately looking for help. They need a new generation to come along and help them. They're desperately looking for somebody that wants to go learn the trade, come in there and wind transformers, wants to come. I mean, they need people to come in and sweep the floors. They can't seem to find anybody that wants to work. I would love to go there, and it has been offered to me to come there. I would love to go there and go to work. The problem is, my life is rooted here in Idaho, and I cannot leave the things that I have going on right now, at least in my life, with child being rooted here and my marriage and so forth. It's not like I'm single and I can take off and move down there with them guys. I would love to go to work there. Would love. And they have this huge building down there. I'd love to take the other side of it. And anyhow, let's get back around to specking out this transformer. So, we know that we're going to have a sag, and that's because the power supply is unregulated. We know the other part of that is that the power supply is too small. You're applying too big of a load to too small of a transformer, and the transformer isn't able to sufficiently keep the amperage output, and the voltage output of the transformer is not able to supply what you're putting upon it. Okay. Those are the things that cause us to have voltage sag. Hold on a second, I want to get something to drink. Okay, got me a drink of water. Got the kids sent off to school. We'll go back to school here for everybody. So, we know that we're going to have sag. The other reason we're going to have sag is that we're going to overspec. We're going to overspec our electrolytic. We're going to go higher in our voltage and electrolytic for a lot of different reasons. But so you're going to see some lead voltage that takes place, where the voltage inside the capacitor climbs up. As soon as you turn the tube on and go into operation, it pulls the tube down. It pulls the voltage down because now there's an electrical load, so it balances out the capacitor. The primary reason for voltage sag in most power supplies, if the transformer is to spec, is because it is not regulated. That is the simple answer to the question. We don't need to sit around and rag about the manufacturer of the transformer. That does no one any good, especially taking into account we only have one supplier left inside the United States, but that's okay. His product that he produces is phenomenally better than anything that has ever come before it. He spends hours upon hours upon hours upon hours upon hours upon hours sitting around thinking about it. So, to the gentleman that's out there that he's going to decide he's going to rag on EPD, I think he might want to sit down and think about why everybody in the market today, the Bluegills, the Ghost Riders, all of these guys, most of them, they will go and get an EPD transformer. It is a solid product. So that being said, now that we've covered all of that backstory and covered all of that stuff, now we can go on and we can talk about how to spec the transformer. So, it says maximum ratings. Right here, maximum ratings. 5,000 volts, okay, at 2.5 amps. Now that's the amount of current and voltage that the tube is going to consume at its maximum output operation. So, that does not mean that the power supply has to rest at 5,000 volts. That means when the transformer is loaded to 2.5 amps, we should have approximately 5,000 volts on the anode of the tube. So if we go and we punch in 5,000, then we divide that by 1.41, because that's the number that Peter at EPD is going to use when he calculates out what we want to do. He's going to come up with approximately 3,550 volts 46.00099299999999. I think the other way around. Okay? Underneath full load, you're going to see the circuit sag. Now remember, there's two different kinds of circuits. You've got yourself a voltage doubling circuit. So we can take a voltage doubling circuit and take, let's say, a 3000 or 2800 volt transformer, and with the use of some electrolytics or oil-filled capacitors, we can create ourselves the other half of the bridge in the diode circuit, and we can kick the voltage up. Now for us to double our voltage, we're going to have to sacrifice what? Our amperage. So if you have, let's say, a 3000 volt plate transformer, so the primary is going to be 220, 230, 240, and the secondary, let's say, is 2600 volts on the first tap, and then your second tap, we're going to say, is going to be somewhere in the area of 3000 volts. We can double that as long as the plate transformer is about 5 amps. That's a voltage doubler circuit. Now if we're going to do a full wave rectification, which what I'm going to do gives us a little bit less sag, it's not going to put so much pressure on the transformer. I'm going to go and spec this for 6000 volts. Because as the transformer starts to load and becomes saturated, our actual output voltage of the transformer is going to versely sag. But we can compensate for this when we get it on the other end. I'm going to teach you this trick. So we're going to take 6000 volts, we're going to divide that by 1.45. Okay? We are looking for approximately 4,200 volts. 4,250. But I'm not going to ask Peter to build to 4,255.31 volts. We're not. And we're going to spec this at 3 amp. Okay. So now we got this number. Let's go ahead and clear this. And we're going to go over here. Now we're going to look at the 6000. Okay. The data lines on this are very thin. It's kind of like the tube was actually specifically designed for only one field of use. Anyhow, maximum plate volts is going to be 7,000 volts at 3.5 amps. So we're seeing a 2,000 volt plate increase. Okay. But if you notice, the drive power is 600 watts. Okay, output power still is 10 kW. But if we click back over here to the 3000, we'll see that in certain modes of operation we're going to have 10,000 volts also. It's not suggested to run this tube as an RF amplifier in this mode of operation to achieve this many watts, because the anode cannot sufficiently dissipate the heat quick enough. But because we have basically the same shmew inside this tube, just a bigger anode, that overall spec rating doesn't change. Now, when I built my 6, I had the plate transformer in there for a 10. And I was able to run this voltage way up. Like, I know for a fact I can put 9,000 volts on a 6,000. You wouldn't believe the numbers I was getting out of it, but the anode was getting so hot you could freaking roast marshmallows on it. So, let's also pop up here and take a quick second. And let's look at the other major variable. We're going to look at our filament voltage, 7.5, and our current is going to be 51.5 amps. Let's go look at the 6000. We're going to be a half volt lower, and it's going to, because of the lower voltage, it's going to pull more amperage, which is 78 amps even. Okay? Once again, 7.5 at 51.5 amps. Remember, this tube is designed to have less voltage put on the anode. So to help control the tube, they back the voltage down, but when you back the voltage down, you're going to see the amperage draw is slightly different. Now internally there is a little bit difference inside the screen structure and so on and so on and so on. We're not going to get into that, but you'll notice that the input impedance and resistance, our output capacitance and the input capacitance are going to stay the same. But when we go and pull the data sheet, the full-blown, this is an amended data sheet. When you go pull the full-blown data sheet, you'll see that the input emulated load is exactly the same and the output emulated load is exactly the same between the 3 and the 6. So we're going to, once again, we're going to pull up, and I'll say 8,000 volts. We're going to divide that by 1.41 once again. And so we're going to get our top tap at 5,600 volts, roughly. And I'm going to show you how to cheat this here in a second. And we're going to spec that also for 3.5 amps on the top tap. Okay. Now, we're done with this. There's a couple different things we can do. You have a primary and a secondary. Okay, primary is where the voltage and amperage comes in from your wall, and secondary is the stepped up or stepped down voltage on any transformer. Now, if our end goal is going to be somewhere around 5,600 volts or 4,200 volts, we want to build ourselves a 15% adjustment window into the transformer. How do we do that? Our input side. If I know for a fact that my line voltage over here is 240 volts, which I know it is, 242.5 volts is what I get from Idaho Power, I can calculate out from my input voltage and dial this number in pretty tight. Now, I don't know what my customers are going to have if they're in California or if they're in Pennsylvania or if they're in Connecticut. The voltages across the grids in the distribution network across the United States are very tightly regulated. But when it comes down to actually getting it delivered to an end user, there's always a little bit of variance. So, my first transformer I ordered, I made sure I got it, and Peter explained all this to me, that you're going to have your primary taps, you're going to have at 0, then 220, 230, 240. And what that allows you to do is each time you change the 10 volts on the input, it's going to give you approximately a 15 volt percentage difference. 15% difference on what your secondary is going to be, slightly. So it's going to allow you to be able to bump the voltage up or bump it down. That makes sense? Okay, so now that we got our basic idea, this is our basic idea on what we're shooting to get out of our transformer. If we actually get this so we can run a 6,000 in the future, like say my customer wants to pull out his 3,000 and he wants to put a 6 in its place, if I provide him a filament transformer that's got a tap on it, let's say for 110, 120, 130, depending on which one of those taps, his output voltage is going to be 8, 7.5, or 7 volts. Last one's important. It's for the 6. The center one's going to be for a 3. That makes sense? And then we tap it out for an 80 amp transformer. So the secondary is going to be 80 amps, but it doesn't matter. As long as we do the 80 amps on the secondary, when we're running it in the lower voltage for the smaller tube, we're going to have 20 amps worth of headroom extra. This 5,600 volts at 3.5 amps, if we spec this out, that's going to be our top tap. Our second tap down is going to be 3,000 or 4,200 at 3 amp. No, this is probably going to be closer to 4 amp because the voltage is so much lower. Now, Peter also pointed out to me that each tap costs approximately 50 bucks. Well, I don't know, man. When you go to spec out an amplifier and you want to go use all top-line, top-notch shelf, brand new components, I mean, you're talking not $3,000 worth of parts, but you're talking like $6,000 worth of parts. I'm sorry. I will spend a little bit more money, and I'm going to go and I'm going to get myself a tap for 3,500 volts. So I'm going to have a tap at 3,500, 4,200, and 5,600 on the secondary side. Now, because we're speccing this top tap at 3.5 amps, as the voltage goes down, the amperage is going to go up that the transformer is able to feed us, if that makes sense. So by the time we get down to that 3,500 volt tap, that number is going to be like 5 or 6 amps. You could run 2 3s on it if you wanted to. So that is how I spec a transformer for a new build with a brand new transformer if the money is in the project for that. Now, if you want to go use some old used stuff, which works great, we are looking for our secondary voltage to be somewhere in the area of what? Well, let's go find out. Once again, we'll go back to our old calculator here. Now I want to show you how to get the power mathematics both ways, front and back. So now what we did is we did it in reverse the first time around. So we had our end goal of 5,000 volts, and we divided by 1.4, back up, 1.41, okay? So that's going to tell us that our end tap is going to be 3,546 volts. Now if we go and we times that again by 1.41, 5,000 volts again. So that's how you do the equation front to back. So if you pick up a transformer, and we're just going to pull a number out of our ass, we'll say 1,780 volts on the secondary, or otherwise the output side of the transformer, something that you're going to attach to the rectifier. This is pre-rectified voltage, okay? We're going to times that by 1.41, and that's going to give you your post-rectified voltage. A lot of guys really struggle with this. Now that I had my great knowledge of Peter behind me, Mr. Peter Eggerman, I totally got my head wrapped around this, and he was kind enough to explain it to me. He didn't explain it to me like an idiot. And so you got to think he's probably got 1,000 people a day that are trying to get a hold of him, or a couple hundred people like me. I have somewhere between 45 and 100 phone calls every day. If I limit each phone call to roughly 10 minutes per call, at 50 phone calls a day, let's say, and I really don't spend that. And that's why when people call me, I'm like, okay, how can I help you? What are we doing? And I don't want to hear the whole life story. I'm just trying to keep them on task, because I'm not getting paid for that phone call, and I never will take any money to take a phone call to answer questions. Never will happen. I just need it to be short and sweet and to the point, and I don't want the guy to feel rushed, but in the same breath, it's like, if I'm on the phone, I'm not actually physically working or doing any one of the projects. I mean, that's anywhere from 100 phone calls is like 16 hours. So if I have 100 phone calls, times 10 minutes, that's 1,000 minutes on the phone divided by 60. That's 16.6 hours that I've spent on the phone with 100 phone calls. I've literally had whole days where I just sit and I talk on the phone all day long with people about their projects. So now we know that if I have 50 phone calls, we can divide this by 2, I'm going to spend almost a full working day at 50 phone calls on the phone at 10 minutes per call. The reason I bring this up is because we want to know how to do the math. So when you call EPD, you can have your information in a very concise, quick note for them. They're going to want to know how to get a hold of you. They're going to want to know your email. They're going to want to know this, and they're going to want to know that, which is going to be your basic contact information. Then they're going to ask you what you're looking for. So you're going to tell them what your primary voltages are. Otherwise, what voltages are you going to feed the transformers? 110, 220. I mean, you're going to do 110, 220. You're going to do 3-phase. It doesn't matter what the input voltages are. You have to know what your primary voltages are and what your secondary goal is. Okay. Now Peter's cool. He'll ask you the roundabout way. He'll say, so what voltage are you trying to achieve? And you're going to say, well, I need about 5,000 volts. He's going to take 5,000 volts, even though he probably knows it off the top of his head very quickly. And he's going to go, okay, well, let's see. So we're going to take 5,000 and we're going to divide it by. All right, so you're looking for, and when he talks to me, he goes, well, Luke, so what you're looking for is about a 3,500 volt transformer. At how many amps? If you can allow him to skip over this process of having to interface with the calculator and just say, hey, I'm looking for a 220. My primary voltage, I'm looking for 220, 230, 240. Secondary voltage, I'm looking for 3,500, 4,200, and 5,600. And I need that top tap to be rated at 3.5 amps. Now, they are automatically, and this is really important, and this is really key, they're automatically going to assume that what you're asking them for is a continuous duty transformer. You don't need it. It's way overkill. The way his iron is designed, I'm not lying to you now, the way his iron is designed, and you're going to save yourself like 30 or 40% of the cost of the transformer by following it up with this simple statement: intermediate duty. Translation: they're going to assume that you are going to spend 30% of the transformer's life is going to spend 30% in operation, 70% in standby. Most of the time, the way that we use it in radio is to those specs. We will spend 30% of the time of the transformer's life on is going to be spent in operation and 70% off. That saves you core, that saves you wire size on the transformer. It saves you all these different things, and it's going to save you weight. So it's going to save you cost in manufacture, cost in design, and cost in shipping weight, which translates into about a 30 or 40% savings in overall cost. And now the way the way he designs a transformer, you might as well just consider it a continuous duty cycle transformer, because even his intermediate cycle transformers, I have never seen the cores get hot. I've never seen the leads of the wires get hot. And trust me, I stood a lot of time standing there and looking at the FLIR with Vader, watching things run, going, wow, the last thing I've got to worry about is this transformer. So, now Vader, on the other hand, we're talking 12,000 volts, 9.5 amps on the top tap, and that is a continuous duty transformer. But now I've got a bunch of these little guys that are laying around here that I've got for the SP220s. Remember, that's a voltage doubling circuit, and that's an intermediate duty transformer, and they're getting the original ones, which he copied. He just literally copied the original one and gave it an updated core. 50, 60 years of duty cycle out of the same transformer before they had a short, and usually what causes the short is not the life of the transformer or how old it is, it's the guy that was operating it and the amount of amperage that he was pulling on the transformer. So I'm telling you, you can do an intermediate or you can do a full duty cycle. It's up to you. But it'd be very handy to know this math, understand how to look at the data sheet, figure out what you're actually looking for, and then when you call the company to have the transformer made, know how to give them the information and give it to them in a succinct way, and to understand the answers to the questions that they're going to pose to you. And that was my goal in this little segment. So now, through the magic of cinematography, we're going to cut this off. I'm going to come back to it later. Like I said, I got a segment I got to shoot on this little guy. And as I've been sitting here watching and talking to you, this is what I've been watching out of the corner of my eye. Check this out. It's a little mini volcano going on over here. Now, I had to move it up onto the heatsink when I stopped to get my little water break and get the kid off to school. I'm going to have to do something different with the base of this thing. I got out my FLIR and I had it sitting on a towel on the table. And I couldn't help but notice that the towel was at almost 350 degrees. And I thought, wow, that's not going to last too long before the smoke starts to come off of the thing. The top of this pot is well north of 450 degrees at the moment. Well north. And the base of this pot is at, now it's on this big giant piece of heat sink, 390 degrees. So I've got this on a big old hunk of aluminum heatsink to keep it from burning my workbench. So, all right, on to the next little bit. Let's give Peter a ring. If you guys knew how long this next little segment took for me to set up, I have to call, had to talk about the things I wanted to talk to Peter about, and then we're horrible, me and him. We get on the phone and we get all sidetracked. We start talking about magnetics and free energy and all kinds of things, and it just takes forever. That and the 3 other times I've tried to shoot this today, my phone's rang. So, let's go over here real quick. He is expecting our call. I would say I need something to prop the phone up on. And the reason we're doing this is I want to demonstrate to you guys the proper way to be prepared. When you call these people, be prepared. Have your figures ready to go. And they'll be ready for you. Mr. Peter, it's Mr. BBI. How are you?
Okay, doing fine.
Well, we need to order a couple transformers today from you, sir.
Okay, shoot.
Okay, I'm going to need on the primary side, I'm going to need 220, 230, 240. In our secondary taps, of course, we're going to need a 0, a 3500. Oh, shit, where's my notes? See, I'm not even prepared. Okay. 0, 3500, 4200, and 5600. And we're going to need that at 3.5 amps on the top tap, and it's going to be intermediate duty.
Okay, 5600, 4200, and 3500. How many amps?
3.5, sir.
3.5, okay.
Do you think you got anything like that on the books?
I'd have to check it.
Okay.
I only got about 600 or so different designs.
Only? Man, you're over there slacking.
So I got to go through the listing and see.
Okay. And then the other one that I need to get a spec, I need to get a quote and a spec on. So like if you could do a print on me for it, and what I mean by that is a design, is I got a buddy of mine that's got a 20 and he needs to get a replacement transformer. So we're looking at 220, 230, 240 on the input as well.
Okay.
And then we're going to do on the secondary, he would like to have 6500, 7000, and 7500. And we need that for 5 amp, and we need that also to be intermediate duty.
Okay, 7500, 6500, and 6000.
7000. Right down the middle. 6500, 7000, and 7500 on the secondary. 6 amp.
Okay, 66 amp, 65, 7000, 7500, 220, 230, 240.
Yes, sir. And the reason I need the print on that is we need to make sure dimensionally it's going to fit in his cabinet enclosure that he has.
Do you know the total dimensions of the opening in the cabinet?
I do not. I have a feeling that we're going to have to get him a bigger enclosure, so it's not too overly important, but I got to have a print to show him. Does that make sense?
Any filament units?
No, sir. I've got the filaments for the 3000 and the 20 sitting here, so.
Oh, okay. Okay.
Yeah. Well, buddy, I appreciate your time this afternoon.
Okay. Do you have Skype?
I do. Haven't used it
You
since
do?
I was dating. That was like 8 years ago. Yeah, I got Skype.
Well, mine is epd. 1.
Okay. Well, I will go get Skype. That way we can do video chat from now on.
Okay.
All right?
Okay, because I do Switzerland, I do Thailand, I do States.
So, now help me understand here real quick. We're going to switch gears, and I'm going to ask you about the Peter Dahl designs. What officially is happened with Peter Dahl? You cannot call and order a Peter Dahl transformer for the smaller stuff, can you?
I think for the smaller one you can get it from Hammond, but I notice all the big stuff they're sending to us.
See, now I've tried to call Hammond several different times, and I've always gotten the runaround, and I've never actually successfully been able to get a hold of anybody there that wanted to talk to me about, like, building a custom transformer for me.
Yeah, because they're in Canada, and you usually have to go through the representatives. So you're not talking with the actual manufacturing unit.
Yes, as I was trying to explain in this video, is that you're one of the last of the very rare Mohicans that hasn't gone and run to Mexico or isn't importing their ship from China.
I just worked with an outfit down in on the island of Palau,
Yeah?
and he told me that Hammond sent them to us. It's actually a 6.6 kVA three-phase transformer for a French transmitter. They got a broadcasting outfit down there. Palau is somewhere between Wake Island and the Philippines.
Yeah. It's a little dot in the middle of nowhere. Out in the middle of the ocean. Yeah.
Exactly.
Now, I got another question for you. What is the highest or the biggest kVA core that you can go with? Because I know that when you built my plate transformer for my box, it's a 70-something, and it was about as big as you guys could go down there. What
kVA was it?
73.5 or something. It was, you told me at the time your cap was 75. If somebody was desiring a higher kV...
Right now we got a 52 kVA out on the floor.
If somebody was wanting, like, let's say, a 100 kVA core, who would you send them to? Is there a company that is willing to go bigger in kVA?
Yeah, I got an outfit I work together with about half an hour from us. He sends the little stuff to me, and I'm sending the big stuff to him.
Okay, so when you consider big stuff, you're talking like 100 kV and up, and little to him is 100 kV and down, right?
Yeah, I'd say 60 above I usually send to him.
So pretty much any amateur radio need or any kind of, I don't know, I guess crazy sea beer need, it's going to fall pretty much within your wheelhouse, because most of our feeds that we are receiving are 70.
When I have a radio station or TV or something that is above 60, 70 kVA, I send it over to him.
Right. That makes sense. Well, Peter, I've taken enough of your time. I know it's at the end of your business day, and I appreciate you being willing to come on camera and talk with us for a few minutes. And I'm going to let you go. I've got to roll on with this. And
okay.
Send me some emails, and we'll start getting this done. And have your son-in-law give me a call. Have your son-in-law, as soon as you guys work up a price, have your son-in-law give me a call, and I will pay him immediately so we can get this going, okay?
Okay, appreciate it.
Thanks, Peter. Appreciate you, bud.
Yeah.
Bye-bye.
Okay, thank you, Luke. Bye.
Bye-bye. Know your voltages and be prepared. Know your voltages and be prepared. Okay, on to the next step. All right, so here we are once again. The parts are starting to show up. I'm a giant fan of don't sit around on the guy's money. Immediately get the parts coming. Packing peanuts. Who the hell uses packing peanuts at work? Ooh, I know what those are. It's 2 of 4 that I need. Yes, sir. Kind of makes me excited. What's in this package? Let's see what's in this one. Oh, and what's in here too? Sweet. So needed. I don't know if you guys have priced the cost of new oil-filled capacitors, something that is not taken from a Henry. Oh, it's not taken from an old Henry generator cabinet or nothing. But I know what I paid Henry Radio for 2 brand new oil fills day before yesterday. Small fortune. 7,500 volts continuous applied voltage at 16 mics. Unbelievably expensive, by the way. Like, breathtakingly expensive. I couldn't believe it. I mean, we're looking at $1,500 for the plate transformer per box. The caps are a third of that. Oh, yes, sir. Caps are a third of that. Unbelievable. What blows my mind is these guys that can do this particular project for like $3,000. It's just staggering to me. They must be using a bunch of old, non-tested, not new parts. It's the only thing I can figure. Damn, packing peanuts again. Now, there's certain things that you want to overbuild. It's not necessary, but we want to add a little bit of operating headroom into the box. And one of those places that I find it's really important to add that operating headroom, now that we've learned a little bit more, my teacher taught me this because he learned it from his teacher who that is a contactor. This is an Allen Bradley C60, which you guys go to look up what these cost. But this is a 100 amp continuous duty contactor. This guy, same size as my fist. So you feed the coil wires on the side here. Okay. What we'll have is we're going to have the wall current come into this contactor. One 110 pole and the other 110 pole. So when we flip that high voltage switch on to bring on the high voltage circuit, you're going to have two of these. One of them is going to go clack. And then sitting over here, this is called a superior Glo Coil. These are getting very expensive. Back when I built Vader, just to give you an idea on cost, this is about a $10 part. Now for a new one, which is what you want, you don't want to ever have a used one of these. This was a $47 part before shipping, or $49 part before shipping, this coil. This is a big wire wound resistor is all this is. So we'll bring one of the phases and we'll piggyback it off the output of the contactor. We'll have a third contactor, or the second contactor here. Here's another Allen Bradley 60, right there. The wire is going to come straight across to this contactor. This wire here is going to go around and go to the transformer. But we're going to have a wire that goes from here to here, from here to here, and on the output side it's going to go around to our transformer yet again. So when we click the switch on for the high voltage, first this relay is going to latch. Then we've got a timer that's set for about 3 or 4 seconds so we can allow the voltage to start creeping up inside that oil fill capacitor. And then this one will latch. Clack. So, dump, 1, 2, clack. Meanwhile, this coil is taking up the shorted load of the capacitor and start pushing electrons on. This thing will heat up. I bet you it doesn't get more than about 90 to 120 degrees at the most. So it heats up just for a second and cools off, and then doesn't do anything else. And all it's there to do is to absorb the electrons as we start the high voltage process. Now over here, these are 2 of 4. These are also Allen Bradley. I don't know if you guys are starting to pick up on the theme here. But when you find something that works really, really, really good, oh, maybe this is all 4. Really, really good, you kind of stick with it. Yep, it's all 4. Yay. Sweet. This is a 32 amp continuous contactor with a 110 volt coil on it, Allen Bradley. This guy right here, this is going to be our filament, our time on, time off, and blower motor controls. We use 2 of those for the box also. You guys would be magog to see how much these cost. These 2 contactors. Google it. You're gonna like, damn. But it works. Okay. This makes me happy. These little tiny porcelain bases are getting hard to find as well. Oh, the camera's telling me I've got 4 minutes of record time left. Hold on a second. Let's fix that. All right, well, I got an hour and 20 minutes to get this done in, and a fresh battery. So this is what I've been wanting to open. This has been out here for half a day. Now, since the last little portion of the video you guys watched with the tube a little bit, it's been a couple weeks. So now we're going to see a constant stream of parts starting to show up here. If you can't guess from what's on the side of the fan here, yep, 110 volt, 60 hertz, almost an amp, 80 watts, RPM 2100 RPMs, max pressure 320, max airflow 300. So, knowing where this thing is going to go, which is going to be pretty close to sea level, I know that I can put up to 300 CFM max, good old cubic feet per minute. But I got this is a special order disc, because I'm not too sure how this is going to work. I don't know if I want to mount this on the side of the deck, if I want to mount it on the back of the deck. I don't know if I want to punch like a 5-inch hole in the side of the cabinet and mount this flush up against a wall. I don't know yet. That's the fun little bit. And I've had a hell of a time finding matching vacuum tuners. Man, you think any of this stuff's expensive? You should see what vacuum tuners new ones go for these days. Good God. See, we don't want loud. We want high volume. So I gotta remember, guys, you gotta sit in the room with this thing running. It's making 403 CFM under no load. So this is designed to have a little bit of back pressure on it. But that should more than adequately cool our tank coil, our relay, our tube, and I think with the proper kind of sound deadening, we can almost make this box run pretty much whisper quiet. Now I am going to put a lift fan at the top, but not as aggressive as Vader, because the way I got Vader set up is that the internal guts, there's vents all the way around the bottom of it, and then there's blowers that push air all over the different parts. But the very top lift fan, it's a sealed system. It was designed to go into the corner of the room and have an exhaust stack attached to it of a minimum of, where I'm at now, 12, 14 inches across conduit to go up, so there's very little airflow, but the idea is to pull air in, cool air in, and then exhaust the heat out the top. Where this one, we're not running with such high temperatures, we're not pushing, we don't have to move so much air, it's not as big of an anode. I know if we go and we look at the data sheet, roughly off the top of my head, I think it's 300 CFM max air pressure at sea level. So we got to think that this 2200 Rip'em motor, which, believe it or not, is almost the same size motor that's on, here, let me show you. Look at this. See the body? It's almost the same size motor. This has got a squirrel and a different kind of blower attachment to it. Wow. This is exactly what I wanted. Oh, thank you, Dayton. Did not let me down. Yeah, max air pressure 320, max airflow is going to be 300. So under back pressure, it's going to be around 300 CFM, which is perfect for the deck. Perfect. This makes me happy. Alright, as more stuff shows up, we'll shoot little segments on it. I gotta go, guys. Got a bunch of other projects I'm working on today. Well, it's starting to fill up over here. So I asked the good old wife to swing into old Wally world. Oh, excuse me. Pick me up some totes. So the first one here we're going to label the Demon. Because I can have a lot of little bits and pieces and a couple pieces that are fairly large, and I don't want them to get banged into or scuffed up. So it's Demon 1. $5 says that falls before the video's over with. And Demon the 2. You know, so I can put my cabinet, enclosures, fans, blowers, all that kind of crap in each one of these boxes. Contactors, all that kind of stuff. In each tote, and slap the lids on them. I don't have to worry about them floating away. The Exorcist. Stuff is going to start showing up here in like mass. I've had to order wire and all kinds of stuff for this. But can't wait for you guys to see what's inside of here. This is a rare fauna of species that's inside of here. This is something that is very rarely seen in the radio world anymore today. That's what's in here. Alright. Now, let's move this out of the way for right now. Okay. Whoa. I bought these from Henry. And I bought these from Henry for years now. And the reason I buy these from Henry Radio is because they're new. There's certain things you just don't want to mess around with, and that's, well, used electrolytics. So, in this big ass box, is the rarer than rare Holy upon holy. The reason they pack them this good is because they're that friggin' expensive. See, I never thought much of the guys that have got to stack like 15 caps together to get the job done. Or, hold on guys, I'll be back. There goes the phone. Sorry, I was dicking with this when the phone rang. And I apologize. I'm involved managing another company I'm working with. This is a rare fauna. I've had so many capacitors in my lifetime where I purchased them, I get them here, they high pot test well, they test well, and then you go and install them into the device, and they run for a little bit, and then you have a failure. The gentleman the two guys that are getting these boxes, they're not interested in any of that stuff. What they want is new. So I'm a big proponent of new, tested, rated. If I have a problem with this cap, I call up Henry and said, I just purchased it from you, I need another one. Replace it. This is a very rare fauna, very rare species. Very delicate little flower. Very valuable. This is a 7.5 kV DC capacitor. It's 16 microfarads. Or UF, pardon me. Very important. You go below this number of 16 and you're going to have hum. You're going to have AC ripple in your signal. You're going to have all kinds of crazy stuff start happening. It might not be perceptible to the ear, but it's going to cause breakdowns in componentry, circuitry later on. It's going to be hard on things. So the 16 is a minimum. They make all kinds of different caps, but I've had a lot of good luck with these Henry capacitors. I really have. This is directly from Henry Radio. They manufacture these things, or somebody manufactures them, and Henry puts a sticker on them. It's probably from that company in Florida, but This is rare. It's about 300 bucks in just this one little tiny can. But it's new. So, let's go ahead and open up the other one here. I don't want to rip the bubble wrap, I want to reuse the wrapping so I can store them in the wrapping. It's the same thing. It's a lot of money right there. Ooh, let me tell you. Alright, let me clean this mess up. I'll be right back. Okay. So this showed up in a little bubble pack. I don't know what it is. I don't even know if it's relevant to what we're doing. Nope. This is my new induction meter that I bought. I'm excited. I can't wait to play with this. Let's see. I think this is from my buddies over at ICA Manufacturing, aka Papaway. Let's see what's in here. Those are all the other little miscellaneous parts I need for other projects. Let's see what's in this one here. It's like Christmas every day. Oh, cool. It's the rest of the Allen Bradley 100 amp contactors I need. Let's see. I think I ordered one extra just in case I could have a spare. What's in here? 3, 4, 5. Yeah, I got one extra. Cool. Let me put this away. Oh man, so it's a whole nother day. I ended up going in the house and I was like, man, this is kind of nice. Just hanging out with my god kid. We ended up playing video games. You know, the stuff normal people do instead of standing alone in their shop talking to themselves. Oh, all right. In here. Hallelujah. This is amp deck number 1. The tube and all the little schmoo that's going to make RF is going to go inside this little flat. Now I get this from my my good friend Tony over there at ICA Manufacturing. Basic jump start starter kit. All one stop in, click buy now buy shop. Jeez. I've got a box. Inside of a box. Did you know, you guys over at ICA, that you're not allowed to use packing peanuts anymore? It's like molesting a dead straw in California or something. Killing the dolphins or some stupidness. So, shame on you at ICA. We love you. Shame on you. These are supposedly the eco-friendly ones. Okay. Oh man, come on. So I can't stand packing peanuts. God damn it. God damn you guys. I'm all out here giving you a plug, and then you totally doink me on the packaging. I'm going to have to call and have angry words with someone about it, so I can feel more manly or something. Son of a dude, cock, fucking son of a... 2 o'clock, goddamn Sunday, 6 in the afternoon. Getting violent brain on my goddamn win. Woo! All right. Now then. Okay. It's 2 damn boxes taped together. Oh, bastards. Oh, boy. Yep. They literally taped one box to another. So we just went through all that fun for no reason. But there's no packing peanuts to spill out on the workbench. Yay. Okay, so let's get this last one out of here. It's gonna be one of the days, just tell. Just tell, it's gonna be one of the days where everything's gonna go sideways every single time. Okay. Michelle, you are the best. That's all I'm gonna say about that. Good job. Thank you. Okay. Now, normally what guys would be doing is they would be unpacking 2 of these. Okay? One would be the amp deck and the other end would be, or the other box would be the power supply. It's not the way we roll around here. At least not if it's in the budget. Then again, most people don't want to pay for what I'm about ready to build. So, on that note, file that. I am going to stack this into its appropriate cabinet, and then I am going to switch into repair guy mode. And that's where I'm going to spend the rest of my week. We shall return. So it's been about a week now since I've done anything with this project. Finally got some more parts in here. What I don't want to show you is this cute little thing that I've got. I ordered these. This is neat. This is going to be our pass-through from the high voltage from the outside of the deck to the inside of the deck for each one of the boxes. They're 10,000 kV, but this is what I think is really neat, is when we hook up our little capacitor meter, that's 800 puff. It's 800 puff, which is awesome, because that means we don't have to put a frickin', well, we're going to put a 1,000 puff doorknob at the bottom of the friggin' plate choke. So we're going to super overkill the plate chokes too. It's just some of the older model stuff that I had laying around, but I got virgin Teflon coming, and we're going to hand wrap our own plate transformers and or plate chokes and everything, and glitch chokes. But this is pretty cool. I'm digging that. Help throw it out of resonance. That'll be fun. Alright, so let's see what's in the mystery boxes here. Hasn't been a week. It's been like 3 days, 4 days. Oh man, come on people. Oh, let's see here. I'll set that aside for right now. So, the trick is in the details, right? I'll give you a little sneak peek. This is kind of slick. I had this idea, and I've had custom dog tags made. I'll show you what they mean, or what they say on them, at the end of the video. You see how we're going to use these. So, these are cool. I got a whole nother set. I think you'll, if you notice the packaging, you'll see it in a previous portion of this movie, this little video. So let's see what's in here. I think this is a high voltage wire, if I'm not mistaken. It is nice soft silicon. It's actually double what we need. So 14 gauge, 15,000 volt, silver plated, high boot neon sign, but doesn't say neon sign. That's what these guys normally use it for. high voltage wire. It'll easily carry a little tiny 3000. Easily. So let's see, what's down in here? Get a little leery when they show up in a reuse box. Well, that's not for this project. Because the way it was labeled, I thought, bad mistake. We're thinking, thought it was for this one. Our new high voltage board has shown up. Look at this. This is what our bleeders are going to be mounted to, and this is what our high voltage rectifier ring is going to be mounted to. That's going to be slick. And let's see, last but not least, I got the dimensional prints from Peter at Electronic Product Design. And by the way, guys, he's still looking for a vet. He needs a semi-retired individual that can come work with him down there. Desperately looking for a guy. So let's see here, where is it? Sucks. Here's a drawing of the custom transformer I haven't made. Here we go. That one. North Carolina. I cannot believe we cannot find a vet that's into radio and is interested in learning about transformers and transformer design and manufacture of transformers in their spare time, that's midlife and can manage to brush their teeth and put on deodorant and show up to work every day. That's what they're going to look like. I'm scooching excited. Just my brain has a hard time getting itself wrapped around the fact that that's what we're having to deal with. We can't seem to find anybody that wants to put a big shout out on Facebook, and it got kind of like a muted response. I'm like, hey man, I'm trying to find a guy a job and got a ton of shares, but nobody wanted to tune in and watch the video. It was kind of weird. Anywho, on to the next step. You know what they say, always start everything out with a good base. Well, I want to order these plates, and this is the foundation to which we are going to build our next project, both of these plates. Something is not square here. Let's take a look for here. All right. Oh. This is not going to be fun, but this is the way it is. This is 1/2-inch aluminum plate. And I cannot remember the grade of this aluminum, but it's hardened. As far as hardened aluminum can go. This one plate is $400. But I said get me 2. They only had 1, and I'm out of time. I've got to get this project started. I've got a very hard delivery date that I have to meet. So that means I get to use my welder, which kind of makes me excited. Let me go through the process of cutting this back. We shall return. $60, $61, or 60, yeah, 60, 61T, 6511. Bevel that back some more. It's not quite the right angle that I want. Looking for like a 1/16 of an inch root landing on this weld. So, trying to make the root landing on 1/3 of the plate. This edge of the plate beveled, and this edge of the plate beveled right. So I got to think at least one minor pass, then a second filler pass, and then a key cover pass over the top, right? So, but also on the backside, I got to also lay a bead down here on the backside as well. So I got to increase my root landing angle on this. It's perfect. Oh, it's perfect. Can't believe I got to spend most of my day working on this instead of something else on this project. Because of one other guy's incompetence and not listening to what I said. Oh well. Flex out them Jedi Knight master ant builder skills. Which I'm not a master of anything yet. I'm still an apprentice. I'm proud of that. Key to being great is always staying humble and knowing where you stand. I don't know nothing. Oh. Let's see. There we go. Filler. All right. Yay. You know, having the luxury of getting to be so many different things in my little sad life that I've had. It's actually pretty friggin' awesome. Always found it interesting how people treat welders. So you tell them, oh yeah, I'm a welder. And they look at you like, ooh. My opinion's always been, yeah, I'm a welder. I could build damn near anything. Alright, let's see, water chiller's on. Let's put on our I don't want to get a sunburn white lily frilly frickin' Miller welding pigskins here. claim to be a master at anything. or something I'm just going to sand flat so I can bolt to the bottom of a cabinet and hold up about 400 pound worth of transformer, which is all going to sit on this plate over here anyhow. So it's just creating unified strength to the cabinet is all I'm doing here. That's what I've spent my entire day doing, is just making sure the floor of the cabinet can't bend. A lot of guys would use just plywood. It's not how I roll. Not how I roll. Okay, so our goal is to go from cabinet panels that are like this and to turn them into cabinet panels that are like this. Now the whole goal is to maintain the sanity of my customer. So amplifiers are notoriously loud. I can't stand that. Customers can't stand to sit there and listen to the fan blow all the damn time, or fans more than one. So what I've done with my own boxes is I lined them with this stuff called Extreme Dynamat. Dynamat with a foam behind it. It's more heat resistant, adds more density, and it traps a lot of the higher end sound waves. Shorter, high end frequency sound waves. Like rotary blade noise. Believe me when I tell you, this is a huge thing. It's going to take and eliminate the sound in the box or in the room from the amplifier by like 2/3. So off we go to do every single panel one at a time. Beautiful. 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 Contact. Here, back, front, right, left. Okay. All right. So the whole point behind this plate is one, we've got to add structural stability to this cabinet. This cabinet alone cannot and will not ever be able to support the full weight of the plate transformer, which, as you guys know, is spec to run a 6000 full out. And the way Peter builds things, it was pointed out to me by my good friend D-Rail that we could probably run a 10,000 almost flat out on that transformer. I was like, well, yeah, maybe. Maybe. So I consider this my first day, even though I've been working on my first day on this project. Even though I have been working on this project now for months and months and months, getting parts and stuff ordered that you guys have seen. You all have visually seen me do this with the previous segments. This is really what I consider to be my first day. So day number 1 is going to consist of getting both cabinets in, assembled. I still have one that's in its packaging. Getting the base plates down and getting the transformer installed. The idea also behind this plate is to get a solid position of ground for this little tiny cabinet. And this will be the last time I get to work on this little particular box up here on the workbench where it's comfortable for my giant, almost 7-foot tall frame. The rest of this I get to work down on my hands and knees with it sitting on the floor for the most part, and a lot of bending over, a lot of straining and lifting. So see if I can knock more stuff off the ceiling rack above me here as I spin this cabinet around. Absolutely gorgeous day today. Absolutely gorgeous day today. All right. Two more lock washes. Two more canuts. Now there's a lot of metal stuff going on here in the corner. The corners of these things from here to here. And I feel, and it's a calculated thing, that there's enough metal mass. I'm tired of this shit dropping on here. There's enough metal mass present in the corner here to support the weight of this thing and it not bend or flex or have any other problems. So if it is not, the wheels unthread and I can build brackets to go on the bottom to help support the weight. Because that transformer is a beast. I literally over spec that thing for a reason. I don't want there to be any weak point. I want the weakest point in this entire build to literally be the tube. All right. Let me get my ground nut. Grade 5 bolts, by the way. Grade 6. I'm sorry, I lied. Grade 6. Okay. Jeez. So, now that I'm about a pound heavier on aluminum dust, and cabinet's all prepped, I think. Let's go ahead and reinsert here. This plate has cost me almost 2 straight days of build, which I'm on such a timeline that I can't really afford that, but I didn't have a choice. There we go. Plate I made. And it fits better than the other one. Aluminum is such a fun thing to weld, because it's like I had to weld, stitch a little bit, clamp it down, change clamp. Thick aluminum like this has a tendency to warp. And we were able to overcome that. Thank Jesus. All right. Almost caught up with where I'm at with the other one. Almost. Do this a little bit, and then I've got the side plates that I've got to do. Wheel is locked. Okay. Back my socket, damn it. All right. Okay. Done with this a little bit for a hot minute. The next step is to do the panels. Man, it sure feels good to be able to get in these totes. So, today's goal, now that we've made some progress, I didn't show it on video last night, but we came out and we got the transformers in. And you gotta remember, I'm in the middle of my work day, so my phone's gonna keep going off. So I went ahead and we mounted the transformers down and got them bolted in. Now we did run into a little bit of a hiccup last night. The standard location for the wheels for this thing, we put the transformer in, the wheels literally went whoop, no. So I was going to build this big complicated bracket system for supporting this, and my wife goes, well, why don't you just take the bolts out that you installed to mount the plates in, drill the hole out a little bit bigger, and mount the wheels on that. And I was like, man, that's a brilliant idea, baby. So that's exactly what we did, and it's worked out great. So I've got these totes that have got every single part, like this here. It's got every single part in here for different things. And today our goal is to get our primary high voltage contacts in, to get our time on timer installed, to get our soft start coil installed, to get our blower and 110 low voltage, when I think of low voltage, 110 volt contactors in for the blower and auxiliary, and then our filament contactor. This is one of these is Allen Bradley's is going to end up being our filament contactor, and then get our filament transformers installed. That's my goal for this afternoon. So now, keeping with tradition, I wanted to share the love a little bit. I don't even know if I can get them out of here right now. Yeah, here they are. Hold on one second. Hold on one second. Here's what I wanted to get out. These are my filament transformers out of Vader, and they're in perfect condition. And I am excited. These things are in great shape, and this is what I'm going to use for my filament transformer on this particular box. Both one in Exorcist, one in the Vader, or one in Exorcist, one in the Demon. There's nothing wrong with these, so I couldn't see buying new ones. When I went to the 40,000, that runs on a 12 volt filament. like 160 amps or whatever it is, 140 amps. So I took these out, and they've been sitting on the shelf, and I thought, man, I'm not going to go buy brand new transformers, like brand new. I'm just we'll use these. I have another one of these that's in my personal, like 3000. It's a 6000 at the moment, but it's a pretty cool design. Depending on how you've got your taps set up on this thing, you can make it run almost damn near anything you want. Incredible design from these guys. Absolutely love it. So I also want to get these mounted up today. That's our goal. Now, instead of doing a step-by-step where I'm sitting here going, okay, so now we're going to put the screw in, we're going to put this nut in, I've got to figure out how I'm going to do my layout plan on the bottom of this. Oh, yeah. Also need to get my brand new oil fields out and figure out where we're going to put those, and then I got to plan into the future and figure out where I'm going to put my rectifier board. So, today's a busy day. Today is a busy day. So, away I go. Well, good morning. So this is where we ended up last night. No less than 3 trips to Home Depot, because I'm a moron. I kept forgetting to grab stuff while I was there. Or I ran out of wire. That was the last thing. I was about 2.5 feet short on the number 1 wire that I put in here. That's 1/0 wire that's in here. Feeding the primary side, which is like super duper overkill, but with the current tube that's in this amp, we're going to be in these boxes. We only need a number 6, but the fact that I don't know where this is going to end up for either one of these guys, I don't know if they're going to be on a pair of 3s, pair of 6s, or a 10 eventually. God, I can't even imagine building a 10 in this small of a cabinet. It'd be like the smallest 10s in history. But it is doable. It's doable. Anyhow, I'm planning for the future, and it never hurts to have bigger wire. Never. So, got the distribution buses in for the 110 volt each leg, and got our soft start contactors in place. Now today the goal is to actually put the soft start in, which is a Glo Coil and 2 timers. So, and that's 1 timer per unit, by the way, 1 Glo Coil per unit. The other thing I did not take into account while thinking this through is how high this thing sits off the floor, which is about that far. So every time I go to slip hardware underneath this thing, it is a freaking chore. But yeah, I want to get the soft start circuit in, and I want to get the filament in, and I want to get the high voltage capacitor in today. And the filament is got to go on its own separate contactor, and then the low voltage DC side for like the relay, cabinet power, that kind of thing. What I mean by cabinet power is, you'll see, it's going to be really cool. And yeah, so soft start, finish the soft start, then filament contactor, and then the low voltage, and then fan contactor is where I'm going to get at today. That's my goal. And high voltage capacitor. And then tomorrow we're going to work on glitch resistor and rectifier boards and mounts, and the beginning of the metering circuit for the high voltage side. Away we go. That's so pretty. And they're exactly the same. The only thing I might do is maybe sneak down in here, and I want to tie up this wire down here. The same thing with this wire over here. Although that number 6 strand is pretty heavy duty, and I don't think it's going to move. For artistic reasons, I think I'll do it. Try to get a couple more video clips as I go today. Very slow, time-consuming process. We'll start right here. So I once did a video. It was called "How a Soft Circuit Works in Any High Voltage Device." So your main principles of this are, you've got 2 contactors, this one here and this guy here. You're going to have a field of resistance, or a mode of resistance, which here I'm using a conical Glo Coil, or otherwise a heating element. and a timer. Okay? And the whole point behind this is to control the electron flow into this mammoth of a transformer. Now, your SB220, your Kenwood 922As, even that Ten-Tech Centurion, and even some of the Ameritron amplifiers use voltage doubling circuits. So they'll take, to make the math simple, a 1,000-volt transformer, and it'll turn that 1,000 volts by using a capacitor bank to double the voltage into about 1,400 volts, or pardon me, 2,400 volts, but you lose half your amperage ability. We're going to do a full wave rectifier on this deal, okay? And the amount of amperage output on this transformer is tremendous amount of power. So we have to control our electron flow into the core, which in turn will control the electron flow out of the core into the rectifier pack, into turning it into DC, and then thusly flipping it and running it across a filtration circuit, okay, which is going to be our oil-filled can, which is going to set somewhere probably in here. Soft start circuit works like this. I call for this contactor to latch. This contactor latches, and it takes one of the phases of 220 and it runs it up to the 220 volt tap on the primary side. Your other 110 volt leg out of the 220 comes around and comes to this 100 amp contactor. Okay, this contactor sits open. Now the electrons have got another pathway they can go. They can go down, come up, go through this conical heating element, back down, up, then back out this leg, and back around and up to the other side of the primary. Now what this does is allows us to have a shock absorber, and we're dramatically slowing down the increase of flow, or the inrush charge of electrons into the transformer. Okay, some guys use resistors. I'm not a fan of that. If you have a problem with this, all you got to do is unscrew it. It comes out like a light bulb. And for about $7-10, you can go buy another one of these off of eBay. They make these in all different watts ratings, all different shapes and sizes, but they all come down. They have a light bulb attachment. Now, the reason this can sit so close to everything in here is because we don't really have to worry about this heating up over past about 80-90 degrees. So, there's a short that's present all the way on the other side of the rectifying diodes back at the electrolytic. You have a resistor that pulls down the electrons out of your filtration cap to get rid of the high voltage to make the circuit safe when the amp is not in use. It sees that capacitor as a short. Well, the transformer doesn't know anything about it. The transformer doesn't care. The only thing that really cares is the diode bridge. That, and then the plates inside the electrolytic. So, if we can control the amount of electrons pissing out of our transformer and slowly feed them into our rectification diodes, we can very slowly and incrementally, remember, things happen at the speed of light when we're dealing with electrons. So slow is just, millionths of a second. We can very slowly trickle in the electrons. Now you got to think of the electrons like BBs or marbles. Each electron stacked up like a marble. Well, when the hose is on, when this contactor is down and this contactor is down, the hose goes from being this tiny little straw to like a 6-inch pipe, and we can flow a bunch of electrons into the transformer. The transformer in turn can spit out a ton of electrons into the rectifier board, right? Okay, so when we don't have this closed to complete the circuit to the primary side, we've stuck a resistor in there per se. This is a nichromium wire that's on this conical heating element. This timer is triggered off of this contactor. This contactor closes, and in turn, we see the electrons get present to the timer. Click, they turn on, and the timer immediately sees the current and it starts counting. Now this is a time-on timer for in seconds, right here. I currently have it set for 5. We're going to see what we get we go to charge our little tiny oil filled. Now, the one that I have in Vader, the 22 kilovolt, 100.1 UF electrolytic, that thing, you can sit there and watch the high voltage on it. Click, you turn the high voltage on, it goes, and it sits there and hovers for a second, and it goes lack, and it latches up the rest of the way. Your ability to inrush current into your capacitor greatly increases as your voltage increases. So what we discovered very quickly with Vader was that if I didn't give it a 4 or 5 second period for this coil to be working and pissing one electron at a time, there's more than that, of course. I'm being sarcastic. We're thinking about our marble analogy. Throwing one BB or one marble at a time into the bucket to start filling the bucket up, it sees it as a dead short, blows up your rectifier pack, and on and on and on. You have problems. So, this thing won't get that hot. Maybe 80, 85 degrees, and it's just for about 3 or 4 seconds. 1, 2, 3, and then off. Doesn't even have a chance to start to warm up. I highly doubt this will even ever discolor. If it has discolored, that means that there's been a problem at some point or another. But the soft start circuit is in both of these boxes. The Demon and the Exorcist. So now the next step is we're going to put our filament transformer in, and then we're going to tie in our contactor for our filament, or tie in our contact for our filament transformer, so that way we can control it with a simple toggle switch, and we can have everything switched on ground. Switching on ground all of our contacts is very important. It allows us to sequence all 3 of the switches together in a safe manner. Okay, there's no 110 volts present on the switch. You just simply provide it ground. The primary switch, which is going to turn on most of our 12 volt functions, bring on all our fans, turn on all our blowers, all that stuff, that's going to be controlled through yet a third or second contactor in front of the filament transformer contactor. So filament transformer, contactor, and then all of our low voltage stuff, all of our 110 garbage that we're going to be turning on and off, fans, blowers, DC power supplies, that kind of thing. Away I go.